All right, this is about turning point theorem. Turning point theorem is where a graph goes from increasing to decreasing or vice versa, and it's literally called a turn. I don't know what you need a definition. How many terms do you see? How many, Elisa? No. There's one right there, there's one right there. Got two terms. You're changing from decreasing to increasing to decreasing. Two terms. Now, how many zeros does this graph have, including multiplicity? What are you saying? 3. Can you tell me why you're saying that's 3 zeros? Okay. Okay. Is 0 24 0? 0 24 is a 24. When we talk about something in the 0, we're referring to its y value being 0. 0 24 is a y-intercept. 0 is an s-intercept. All right. This is a y-intercept. It's not 0. That is not that. So I'm not disagreeing with 3. Anybody tell me why it might be a 3? Crickets. Okay. This is a touch. That's even multiplicity. Don't memorize things, kids. Even multiplicity. What's the lowest even number you're aware of? 2. Happens. M is at least 2. Crossing the exceptions here. That's odd multiplicity. Now, I'm tired of writing multiplicity, so odd M. All right. Odd multiplicity. What's the smallest odd number you're aware of? 1. Bill, were you aware of this? You just weren't talking? I know, but earlier the question was being asked. Were you aware of this? You just weren't talking? You gotta remember it, kids. Writing is how we remember. Multiplicity is at least 1. It's the smallest odd number there is. So I wasn't disagreeing with the 3. I was curious what the thought process was behind it. So I have something that happens at least twice, and I have something that happens at least once. What's the least degree it can be? 3rd degree. So we have at least 3 zeros. It is at least. It's not 3. It's at least 3. Which means we are at least some 3rd degree polynomial. That's Q. Well, the slide is about turning point theorem. This is the only example really you've seen to come up with it. But what do you think the relationship is between turning points and least degree? How do you turn a 2 into a 3? By adding what? 1. Least degree is TP, which stands for turning points, not toilet paper, plus 1. It's a really easy thing. Really, really easy thing. All right, so that's what you need to know. That's the layman's terms. The actual turning point theorem says the power function actually it's worded a little bit differently, but I like to use the word power function. A to the xm. So I'm talking here about power function. What is a power function? Oh my gosh, y'all have no vernacular. What is a power function? First term in standard form. Maybe I should do both of them quizzes. You don't have to prove what I'm saying if they do. Well, the door used to say Japanese. You might remember they used to say Japanese, it's a lie. Because I use words that you don't understand. All right, so first term in standard form. So the power function ax to the n has at most n minus 1 turning points. That's the most it can have. It's the absolute most it can have. Now, I know on Friday's test, I've got a really easy question that I fully expect way too many kids to miss. But it'll be something like 3x to the 75th power plus a whole bunch of other stuff that doesn't matter because the first thing you see is 3x to the 75th. That's the power function, isn't it? Has at most how many turning points? What's it have? 74. Take the exponent, subtract 1. I'll mark that thing wrong all day long. It'll happen. All right. We're not going to do all of this one. How many turning points does this guy have? 3. Make sure you see them. I'm convinced not everybody can see them. 1, 2, 3. What's that mean? It's going to be at the least. Least next to the 4. We are going to do the next one. That one. And I've got a question on your test. It's got 5 sections, each section worth 3 points. And one of the questions is obviously this: based on the graph, what is the least degree for this polynomial? So how many turning points does it have? So it has 2 TPs. And what do you add to that to get the least degree? You add 1. That's going to be an x cubed. Now, there's more to it than there should be, these notes say. Something I'll also ask is, based on n behavior, the function is, that thing right there starts high and ends low. What is it? What kind of x to the odd? Negative. You've got to memorize n behavior. On a multiple choice test, knowing that you have a negative symbol out front helps you. How does it help you? It eliminates half of it. Anything that's positive, you just throw out the window, don't you? So little things like that make a big deal. Let's see, the other thing that's on there, and we'll need it to do this part right here, is what are the zeros and their multiplicity? Remember, we abbreviate multiplicity with m because nobody wants to write it over and over and over and over. So what are the zeros? -4. What's the other one? X equals 3. Is 0.24 a 0? No. Don't do it. I'm glad I heard that mistake up. Every class has made it. All right. Multiplicity of x equals -4. What is it? 2. Why is it 2? It's a touch. Those touch starts with a T. 2 starts with a T. That'll really do it, kids. That will literally do it for you. That'll get you through Algebra 2. All right, 3. What's its multiplicity? 1, because you are passing through or crossing the x-axis. All right, so we're about ready to go ahead and write this thing. Let's call it f of x. What does every form start with? A. I know that -4 is a 0. What is the factor? X plus 4. Now, where does multiplicity show up on the factor? Squared. Because I would write this thing twice, wouldn't I? Does that make sense? All right. I know that 3 is a 0. What's the factor? There you go. Next move. Huh? No. I need to figure out what A is. Miley, what's f of x fancy for? Y, good. Make sure you guys know that. There's a point up there. What does every ordered pair give you? X and Y. That's always going to be true. If you have an ordered pair, you have an X and a Y. And what can you do with them? Plug them in. So f of x, according to Miley, is fancy for Y. She's right. What's it going to become? 24. And it must equal A times a 0 plus a 4 that is squared. And some of you guys, when we write stuff down, you just kind of sit there and you wait for the answer. You don't need to be doing that. I mean, granted, we might move faster than you, but you need to be thinking. You need to figure out what's married to that A. Now, 4 squared is 16. 0 minus 3 is -3. 16 times -3. What is it? Huh? What's married to A? What's the number? You got 16 times -3, kids. -48. I'm not sure what y'all are thinking. I'm not sure some of you are. What's the opposite of marriage? Divorce. Divide both sides by that -48. And hopefully you can figure that out. What's the A value? -1/2. Anyways, put that in the front like it belongs and you've got your equation. Order of the factors doesn't really matter. I don't remember how much time I had when I made this test. I probably put x minus 3 first. Usually you put factors in increasing order, but who knows? Doesn't really matter. All right. I wanted to make a joke about y'all not being able to do math, but I don't know how to make it. All right, here's the last one. Actually, let's do a different one. Table shows the consumer price index, CPI, for several years. You may not have heard that, but the government tracks prices to determine what we call inflation. It's kind of a big deal. They monitor it all the time. Because if the cost of goods is going up too fast, what do you think is happening? People can't buy food. All right? The price that things increase needs to at least be matched by wages, by and large. So it's kind of a big deal. It's called CPI. It says, find a cubic function to fit this data. So what I have here is I have an independent variable up top, x, and CPI is dependent upon the year, so CPI is y. How do we put x's and y's in a calculator? Stat edit, that's right. A lot of people today have been saying matrices. This is not a matrix system. It's something you did in Algebra 1, it's something we've done in Algebra 2. The instructions are more or less on the preceding slide, too. But you've been here before. You'll go to Stat, you'll go to Edit, and how do you remove stuff from a list? Go all the way to the top and press clear. Do not be that poor soul who presses the delete key, because if you go all the way to the top and you press delete, like I'm about to do, what disappears? The list. Then nothing's going to work right. Anyways, X is in list 1, Y is in list 2. Boy, this is old data, isn't it? I need to hurry up. 8, 9, 11. There is a question just like this. It's same context. There's a question about cubic regression on Friday's test. It will hopefully go well. We shall see. Friday's your payday. Friday's where you see the fruit of your efforts. If your efforts have been good, the results are good. If your efforts haven't been good, the results won't be good. All right, so it says cubic function. Have you got everything typed in? What do you do? You don't have to quit, actually. I'm just going to stat. Now, it's cubic. Cubic is a 6, right? Scroll on down to calculate, and the calculator gets back an equation. And it's given to you in standard form. Where you see an A, do that. Where you see a B, do that, and so forth. On the test, I'll go out 4 decimal places. I don't have it there time today. So negative 0.022 x cubed plus 0.324 x squared plus 4.401 x. The last one, plus 86.202. So that's the first part of the question. The question is, figure out what the CPI was in 1970. Now it says that the X values are the years since 82. So what's 1970 compared to 1982? That's right, this is 1912. So now that you figured out the time, what do you do with it? Plug it in. I will say that you should not do this. This is only valid for these years. Anybody who tells you they have a mathematical model that's going to predict the future based on the present is lying. Every math teacher says models are only valid for the time they're really correct. And then they take these models and they're blown back. They try to predict the future. It doesn't work that way. Anyways. See what we get. The reason it's a horrible model is because you know what X cubed does. It falls fast and rises fast, doesn't it? You can't predict the future with a cubic model. It was supposed to be negative 12, wasn't it? Yeah. I don't know how green of a person you are, but they've been predicting global warming and massive floods my entire life. It ain't come true yet. I'm not saying you should just throw your trash out on the side of the road. But I will tell you that this world is cleaner now than it was when I was a kid. It really is. I got 118.106. That could have been good. You guys agree, anybody agree with me? Agree, do you agree? Do you agree, Natalie? You gotta read it. You got error. Are you using the minus sign instead of the negative symbol? Does anybody agree with me? I got, okay. Yeah, case reason. We're good. Case reason, yeah, I'm right. Plain and simple. Well, so y'all gotta figure out how to push some buttons. Now, this also, figure out how to push the buttons. So 118, 118. Anything over 100 is inflation, anything under 100 is deflation, by the way. 100 means nothing is changing. Rise above 100, prices are increasing. Below 100, prices are decreasing. So that means we're done.